Okay, 7.2, we're going to be multiplying and dividing. Messy fractions, rational expressions. You do not need a common denominator to multiply or divide fractions. You multiply across and simplify, or you simplify first, then multiply across. We are going to be simplifying first, then multiplying. So 2 and anything on top and bottom that has a common factor can be reduced. There's a 5 on each of them. 2 over 8 reduces to 1/4. Multiply across, multiply across. We're here. The x's will simplify out to 1 whole, and 2 divided by 2 is 1. 4 divided by 2 is 2, so it reduces to 1/2. So what we're going to be doing differently now is we need to make sure we factor completely both numerators and denominators, then divide out common factors. So factor, factor, simplify, simplify. So here we have no addition and subtraction signs, so there's nothing to factor, but you can write it in expanded notation. And I'm going to divide out common factors. I have p divided by p, q divided by q, and the 2 and the 6 will be 1/3. 1 2 here, 3 2's here. So I'll be left with 1p on top. I don't have to put the 1, I can if I want. And a 5 times q on the bottom, and you can see nothing is the same anymore on top to bottom, and it's simplified completely. If I like writing it in expanded notation, but you do not have to. So 2y's will divide out, the x will. 4 divided by 8 is going to be 1/4 here, 2 here, so I'll be left with 2 over 2, which reduces to 1 whole. So now we have to make sure we factor everything that we can. So we do not need to factor 3t. I can write it like 3 times t if I want. Doesn't make a difference. In this denominator, I have a common factor of a t. I'm going to pull that out, put up my parentheses. T, I'll be left with t plus 5. Here I have a GCF, a common factor of 3. 3 times t gets me 3t. 3 times plus 5 would get me 15 over 6t. So t plus 5 is going to divide out to 1 whole. One of the t's will go, and 3 over 6 will be 1/2. So I'll be left with 3 times 1 on top, 2 times t in the denominator. Example 4, I have to factor all numerators and denominators first completely. I have a trinomial with a leading coefficient of 1, 2 sets of parentheses, break up my x, 1 of each sign, 2 numbers that multiply to 20, that combined a -1, it's going to be -5, +4. Here I have a GCF of 5, pull that out, times here I'm going to have a 2-step. So I'm going to GCF this 15 out up here, and I'll be left with x squared minus 1. Now I still have a difference of perfect squares. So I'm going to have 15, 2 sets of parentheses, break up my x, the 1, square root, 1 of each sign. Down here I have a GCF of 2. 2 times x will get me 2x. 2 times plus 4 will get me 8. And now I'm going to simplify everything I can. Have this factor divides out, this divides out. 15 divided by 5 is going to be 3. So we're left with 3, x minus 5, x minus 1 in the numerator, and 2 in the denominator. The next example, I have to factor everything completely. 2 sets of parentheses. I don't know why my pencil's so light. Break up my y, 1 of each sign. 2 numbers that multiply to 21 that subtract a positive 4. So it's going to be 7 and 3. The 7 has to be the positive because my leftover is positive. In this denominator, pull this 3 out. I'll be left with 3y. 3 times 3 is 9. Here again I'm going to have a two-step. They're both divisible by 6. I'm going to pull that out first. I have 24 divided by 6 is 4. But now I still have a difference of perfect squares. So I'm going to continue to factor completely. y, 2, 2, plus, minus. And here this denominator is factored. You can cancel anything on top and bottom, diagonally or above. This goes. 6 divided by 3 will be 2. So everything in the denominator cancels to 1. Y plus 7. Y minus 2. I have that, and that on the top with no denominator, so I don't have to write it over 1. Here I have to factor all numerators and denominators. They're all trinomial squares. So I'm going to factor all 4. And boom, they're all factored. Some of the sections in chapter 7 are rather long, so I'm trying to save time. What I meant to say before is they're all trinomials whose leading coefficient is 1. So they all factor into 2 binomials. Just watch your signs. Now I'm going to cancel everything that I can. Get one of these, x minus 2 from the top to the bottom. They divide out to 1. And I'm left with x plus 5 over x plus 1. Now we're going to be dividing fractions. Remember, you do not need a common denominator. You're going to keep the first one, change the operation of multiplication, and take the reciprocal of the second one. So keep, change, flip. So you keep the first fraction, change to multiplication, reciprocal of the second, multiply across, and simplify. So we have to remember to factor completely first. So in this step, I'm going to rewrite into multiplication and factor. So this numerator has a common factor of 3. 3 times 2x plus y. This denominator will be 4. 4 times x minus 3y. Times, I'm going to take the reciprocal of the second one, so the numerator will become 2x minus 3y. And common factor of 5 here, so I have 2x plus y. Now, divide out my common factors to one whole. The 2 and the 4 divided by 2. I'll be left with 3 times 1 over 2 times 5, which is 10. So you do not have to write in expanded notation, but you can. Keep the first one, change to multiplication, reciprocal of the second. 2, 1, 2, 3, 4 x's. So 3 will go away to one whole, 2 y's. And the 8 and the 2, 8 divided by 2 is 4. So I'll be left with 4y squared in my numerator and x in my denominator. And you can clearly see it is simplified completely. Here I have 2 sets of parentheses. 2 numbers that multiply to 4, add to 5. GCF of 3 out. Change to multiplication. Flip my second. Difference of squares, factors out. Reduce everything that I can. The 6 and the 3 will go to a 2 on top. The 6 is bigger. So I'll be left with 2x over x minus 1. This is all one factor, this x minus 1. It will not simplify with this x. Completely different. Whatever this x is, say it's 5, this is 1 less than that. It's 4. They are not a common factor. I'm reaching my time limit on this video, so I'm going to factor completely, keep, change, flip for you. So I factored everything, kept the first one, multiplication, reciprocal of the second. Now I'm going to cancel everything that I can, divide out to 1. Everything reduces, so anything over itself is 1 whole.